This video is a quick review video on graphing exponential functions and identifying their key characteristics. So I'm going to graph two exponential functions today and identify their key characteristics with you and kind of remind you on how to think through these processes. If these two examples aren't enough, please go back to previous videos on this topic for more in-depth and longer review content. So to graph this, I'm going to make a table in my calculator first. I'm aware that I have a parent function of 2 to the x, so I know that's where I'm starting from. The rest of my process here, I know this transformation is up 4, and it's my asymptote. So I'm going to go to my graph here and kind of put these things down. So I'm going to write my equation. So we're graphing y equals 2 to the x plus 4. Okay. So I'm going to put in my asymptote at y equals 4. 1, 2, 3, 4. Remember, your asymptote is an invisible line, so I'm going to dot through this line here. Okay, my graph cannot cross this line. Okay, so since it can't cross this line, I'm going to need to find all the points that go above it. So if you have a graphing calculator, you're going to click y equals. If you have a scientific calculator, you go to your table function. I'm going to clear out my function. I'm going to write 2 raised to the x plus 4. Enter. Here, remember, you have to edit your function, and you're going to clear it out. 2, X box button there, raised to the x, arrow over, raised to the x, arrow over, plus 4. I'm going to go to second graph to build my table, and I'm just going to hit enter here to build my table. And they should show up to be the same. So looking at what I can graph whole numbers. Those numbers are easy to see, so I'm going to work on that. I have a point at 0, 5, plot that point. At 1, 6, at 2, 8, so 7, 8, and at 3, 12. So 8, 9, 10, 11, 12. And then I'm going to go off my graph here. Remember, when you make this graph, you're going to get super close to your asymptote. Notice that's where I start. I'm going to get super close to my asymptote and curve it up. Okay. Get super close to my asymptote and curve it up. Okay? So there's my graph. So let's use this graph to identify these characteristics here. So the domain. Our domain doesn't change. It's negative infinity to positive infinity. So from left to right, both of those keep going on in both directions. My range is what's different though. My range starts at the bottom, remember, and moves to the top. So at the bottom, I have my asymptote of 4. And at the top, I'm going to keep going up. Those y values are going to get bigger and bigger. Notice I put 2 parentheses because I'll never reach either of those numbers. Let's look here. X-intercepts. If my asymptote is at 4, do I ever cross the x-axis? That answer is no, so there's going to be none. Do I have a y-intercept? Do I cross the y-axis? The answer is yes, and if you look at your calculator too, we have 0, 5 as a coordinate, so that's a y-intercept. if I read from left to right, my exponential function is going up a hill. It's going up that slope of my roller coaster first. That's increasing. And remember, we're always increasing across the entire domain. So if they ever ask for an interval, it's always negative infinity to positive infinity when we talk about exponential functions here. We've identified our asymptote. Remember, that's an equation though, y equals 4. That asymptote is an equation. It's at y equals 4. Let's look at end behavior. What's happening at the ends of our graph here? The first one is when x is positive. So when x is positive, this is where my graph is going. That arrow at the top is headed up. It keeps going. So my x values are positive. My y values keep getting bigger and bigger. So I'm going to put positive infinity. Then I have this equation here, negative infinity. Where's my y going? So here's negative x values. This line is flattening out at our asymptote. Our asymptote is 4. So remember, when we talk about end behavior, my asymptote has to be one of those end behaviors. Whatever one it is, it has to be one of them. Let's talk about rate of change really quick here. So let's talk about finding a rate of change between, let's go from 0 to 4. So remember, I can ask you to find a rate of change just like that. Or I could say find the rate of change from 0 to 4, and I'm asking you the same things. I've given you two x values. What's another name for rate of change? Slope, right? So remember, we want to use that y2 minus y1 over x2 minus x1 formula. I have my x values. I'm going to use my table to find my y values. 0, 5, 4, 20. So 0, 5, 4, 20. So this is going to be 20 minus 5 all over 4 minus 0. So this is going to be 15 fourths. And we can leave it just like that fraction. Rate of change are better left as fractions so we can count rise over run. Let's look at this next one, but I want to make an adjustment here. Let's change this stretch to a reflection. Let's change the stretch to a reflection so we can practice what that looks like here. So we're going to have to go back to our calculators. Let me erase my graph here. So we're going to graph y equals a negative 1/3 x minus 1. So we're going to graph. Okay, so looking at my two things here, second quit. Okay, so I'm going to go to y equals and clear it out, negative. I'm going to open up a set of parentheses and do 1 divided by 3 for my fraction, raised to the x minus 1. Here on this calculator, when I go to table edit function, I'm going to say negative. I'm going to use parentheses still, but I'm going to hit the fraction button. Remember that floating fraction? 1 over 3. Close it. Raised to the x minus 1. Create these tables. Second. Why won't this work? There we go. Table edit function. Nope. That's not what I want. Dang, now at negative 1 divided by 3. Messed it up. Okay, there we go. Okay, so again, let's graph the things that we can see. So there's my tables. I'm going to pull them aside to graph. Looking at this equation, I have a reflection That's a transformation because 1/3 is that parent function. And then I'm going to the right one. Okay. So what's my So what's my asymptote then? I have a reflection, a parent function, a right one. What's my asymptote? If nothing's written there, your asymptote is at y equals 0. So let's graph that on our graph here. Right across this y-axis, I'm going to write y equals 0. There's my asymptote. Okay, I can't go past that. So then let's look at our table we made here. I have a lot of fractions, but I have 1, -1. I have 0, 1, 2, 3. I have -1, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have -2, -27, which is way off my graph. Well, let's get really close to our asymptote and curve this thing down. Okay, so there's our function there. Just like that. We have a reflection. It was flipped over the x-axis. So remember our parent function? There's a rough sketch of what that parent function would look like. So we have this one function here, and we flipped it over that x-axis. So I just wanted to draw that parent function into let you see. And here's our transformed graph. Okay, so let's identify these characteristics. My domain still hasn't changed. I don't know where to put this to best help us here. My domain still hasn't changed. -infinity to +infinity. My range, remember, goes from the bottom of the graph to the top. So let's take a look. At the bottom of the graph, we see an arrow. That arrow keeps pointing farther and farther down. So we're going to start with -infinity. And then as we climb up to the top of our graph, we get to our asymptote, which is 0. So that's how we would write our range. If my asymptote is the x-axis, do I have an x-intercept? Nope. Do I have a y-intercept? Yes, and in your calculator, it's at 0, -3. Okay, so here we are. So there's our x and our y-intercepts. We've identified our asymptote. Let's identify increasing or decreasing. So from left to right, as I follow this, what's happening with my y values as I move left to right? They're increasing. They're getting closer and closer to 0. So this function is still increasing because of that reflection. And remember that interval of increases across the entire domain. Okay, let's talk about end behaviors next. End behavior, we have when x is positive was that first one. So when x is positive, my graph is flattening out. My graph is flattening out at my asymptote, which was 0. Then when I look where my x values are negative, this arrow keeps going and going and going towards more negative y values. So there's my end behavior. Let's do another rate of change problem. Let's do it from -2 to 1. Or -2 to 1. So remember, those are x values. You can use your table and your calculator to find the y values. And then we use our slope formula. y2 minus y1. But remember, it's minus a negative. And there's already a negative here. So minus a negative, y2 minus y1, all over x2 minus